the second problem, we have a demand function. I'm sorry, the price is a function of demand. So we have a price function or demand function, whichever way you want to read this, given as stated here. And we want to find the revenue as a function of the demand. Okay? Now, one difficulty with this problem that I'm going to have to remedy before we actually print off a set of tests is that the domain of this function is x from 0 to 240. The reason for that is that if x is greater than 240, when you multiply x by negative 2.5, you get something that's less than negative 600. You put 240 into this and you get 600, and it's negative. So the price function would be down to 0. And clearly that's not going to happen in the real world. You're never going to have a price that reaches 0. It might get kind of close depending on demand and market values, or market influences, but it's not going to be 0, and that's not going to be a meaningful part of any model. And here we're asking for the revenue at 425, which is going to give us a very negative price function. That means that the company would have to pay you for you to buy the object, the commodity or whatever it is. Okay, so this is not a good realistic problem. I'm going to have to fix that problem so it doesn't generate values here that don't fit within this excuse me, range. That'll be easy to do. I just have to remember to do it. Okay, so having said that, what do? We want to find the revenue. Now, you have to know that revenue equals the price, which is how much somebody's going to pay for the object, times the demand, or the number sold, or the number to be sold. Okay, so obviously the price is how much you're going to pay for it. You multiply that by the number sold, which we also call the demand, and you get the revenue, which is how much money you take in. Now that's not the profit. You have to subtract off what it cost you to make and market the object, but we're just looking at revenue here, the simplest possible calculation. So you have to know that you got to multiply the price by the number sold or the demand in order to get the revenue. And of course the price is right here. That's negative 2.5x plus 600 multiplied by the number sold or the demand, which is x. So that equals negative 2.5x squared plus 600x. And we can say the revenue is R of x. So that R of x in its simplified, expanded form is this. So now what's the revenue when we sell 425 of the objects? Well, very easily found. R of 425 equals negative 2.5 times 425 squared plus 600 times 425. I think the problem on the actual test was 429. I was reading it without my glasses. That was a little too close to it, so I misread it as 425. But it's going to be very clear what you do with the problem as it was stated. And then this equals, well, I'm not going to do that arithmetic in my head. 400 squared is about 160,000. 500 squared is about 625,000. Something's wrong. 160,000. 250,000, sorry. So that's going to be around a little less than 200,000. That's going to be around negative 500,000. You multiply this by this, you get something much less than that. You do get a negative, and it doesn't make any sense, but that's what you would get. Might be hard to interpret it, but the interpretation is simply my program generated a number here that didn't fit within this range. Okay. The basic idea, though, is that revenue is price times number sold. You multiply the price by the number sold, that's how much money you're going to take in. Number sold can be referred to as demand, And when we get that straight, we just take the information we have here and we immediately get the price times the demand. Price being this, demand being X. Multiply that out, we get the function, we plug the numbers in, and we get our result.